Yeah, good morning, Vish. Okay, so in the previous class, we were learning about decision making. So we learned that there are two types of decisions, right? Program decisions and non-program decisions. The non-program or program decisions are the ones which are repetitive in nature. So those decisions are made by following a set of rules. We already have a policy or rules of procedure to be followed when such decisions are to be made, right? Those decisions are repetitive in nature, and those can be easily made. That is, no matter who makes the decision will be same, right? Because we are following a set of guidelines. So that is program decision. So these decisions are normally made by lower level managers. Similarly, we have non-program decisions also. So non-program decisions are unique to a situation. The situation will demand us to make a decision. So we don't know what is the procedure to follow. So we have to make the decision on the spot, right? Those kind of decisions which are not repetitive, okay, which is not defined. Okay. Those kind of decisions are known as non-program decisions. So these decisions are usually made by the higher up, that is mid-level or even top-level management, right? So programmed and non-programmed decisions. There are two types of decisions. So uh, for making non-programmed decisions, we have different methods, right? Delphi method, nominal group method, right? Experience is there in using certain statistics and tools. Also, these decisions can be made also based on our experience. Now we'll see what are how decisions are made under certain conditions. That is under certainty, uncertainty, and risk. Okay, how decisions are made under certainty, uncertainty, and risk. So decisions under certainty. So this is certain implies that we are certain of the future. Okay, we are certain of the future, or that we assume that we are, right? See, whenever we were talking, we said that future is unpredictable. We don't know what will happen. We are assuming, right? That was the case when we made decisions. Because we are assuming that it is certain that this will happen. Okay? In such a condition, we are making certain decisions. That is decision under certainty. That is condition is we are certain of, rather we assume that we are certain. Okay? So in this condition, the common technique used for making decision is known as linear programming. Okay, we use a common technique for decision making under certain linear. This method has benefit of variables similar. Have x plus c plus c for d. Similarly, what we do is in here our profit or benefit is expressed in terms of equations, mathematical functions. Let's say, for example, like uh, more sales plus less marketing will be equal to profit. Less production plus less wastage is equal to. Similarly, mathematical function. So our desired benefit or profit is expressed as mathematical function, right? So like equation C, the solution, the solution of this equation is the set of values for decision variable that leads to maximum benefit subject to certain constraints. So we made equation like maximum sale plus minimum marketing is equal to profit, right? Or uh, maximum less production cost plus less wastage is equal to profit, like that we made. So when we solve these equations, when we solve these functions, will get a set of values, right? And these values, the solution, these values are values are the, these are the values of the decision variables. What are the decision variables here? Maximum production, minimum wastage, maximum sale, minimum marketing. All these are variables. And when we solve this, when we solve the mathematical functions, we and it leads to maximum benefits subject to certain constraints. There will be some constraints, right? Under certain constraints, what is the best? This is making certain. But what is this? Due to the business world of today, very few decisions are under certainty. Okay, so maybe may almost you can so tomorrow what happens? Because business change day to day. On a trip, everything changes on a day-to-day basis. You cannot make a decision is a certainty. Okay, so what is distance under certainty? The condition is we are assuming that we know what will happen in the future. We are certain about the future. That's our assumption. Then what happens is we will be putting up equations or functions, that is benefit or profit is put in terms of equations, functions. Solve those equations, and finally we get the set of values. Set of values means for each of the decided variables, like what is the maximum production, maximum minimum marketing, like that. Those are each of these variables will get a solution. This solution will lead us to maximum benefits subject to certain constraints. But the problem is that because of very few decisions can be made under certainty. Okay. So next is the uncertainty. Under certainty. So uncertainty occurs when there are several future states of nature, but the probabilities of each of these occurring are not known. Like we know tomorrow lockdown may be lifted, but tomorrow lockdown may not be lifted. So we know there are many possibilities are there, but we don't know what is the probability of occurrence. What will happen? We don't know. We know this. These are the possibilities. You know what are the different possibilities, but we don't know what is the probability of each of these occurring. That is uncertainty, right? So in such situations, decision makes us choose from the following approaches for decision making. So we have different approaches. First one is maxi-max solution. Maxi-max solution. So here what happens is this approach is taken by optimistic decision makers. Okay? So here assume that everything, whatever will happen, best will happen. Okay? So maxi-max, everything is maximum. Maxi-max. Okay, everything is best, maximum. So this is selecting the best for each decision. The decision with maximum payoff. So here what happens is each decision, whatever decision is chosen by the manager or the decision maker is believed to be the best. Okay, deals with the selecting the best possible outcome for each decision and choosing the decision with maximum payoff. So there will be many. We will have to make many alternatives, right? So what we said earlier itself, decision making is taking the best course of action from the alternatives so that we'll achieve the desired result. So we have different alternatives. So in this maxi-max solution, what happens is we'll take for decision A, B, C, D. We have 4 decisions. So we will consider decision A. When decision A is chosen, what is the best outcome of decision A is considered. That is, best outcome of decision B is considered. Best outcome of decision C is considered. So this is selecting the best possible outcome for each decision. Okay. So we have 4 decisions, 4 alternatives: A, B, C, and D. The first alternative, what is the best outcome? We'll see what is the best outcome. So second possibility, what is the best outcome? For for alternative C, what is the best outcome? D. Among these, this is the maximum payoff. We have a scenario, so that's why we call it optimistic, maxi-max. Okay, the maximum solution, selecting the best for each decision and choosing the decision maximum payoff. Right? Clear? So this is the optimistic decision maker, and assumes whatever the action taken, that will happen. Okay, whatever is my decision, is the best. Okay, that is maxi-max solution. The second one is maxi-min solution. Okay, maxi-min. So maximum and minimum. This approach is taken by pessimistic decision maker. Okay, here what is happening is the decision is selecting an alternative, so a worst outcome is least bad. Okay, so what happens again? We have four alternatives A, B, C, and D. So you see what A. What is the worst outcome? So we make some okay. Worst and B. What is the worst and B? What is the worst thing? Or worst things is the bad, which is the bad. Deals with inequality. So our worst outcome is least bad. So suppose we have for A, C, and D. For alternatives are there. What is the worst? What is the alternative? What is the worst that happens for D? What is the least worst outcome? Least massive million. So this thing, that thing, lost. That is maximum meaning solution. Then max max any solution before making optimistic. Maximum max not I think he's pessimistic. So for those kind of person, he'll make see. You understood the term optimistic and pessimistic, right? Optimistic means he'll assume everything will happen. Whatever will happen, everything will be good. Nothing bad will happen. Pessimistic means he'll see only that bad things are going to happen. Okay? That's pessimistic and optimistic. The term meaning. So minimax solution is useful for neutral decision making. So what happens is here he's neutral, not considering bad, he's not considering good. The decision maker may choose the position between optimism and pessimism. So the position is between maxi-max and maxi-min or both. Okay. Here it's not considering the best or the worst. It's considering in between that. Okay. The fourth one is Laplace criteria. Laplace criteria, what happens is assumes the probability of occurrence of all future states are equal. Okay. So we said earlier itself, we have many alternatives for future. The probability of occurrence of all future states are equal. Okay. Lockdown to be withdrawn or lockdown extended. All these things are equal. Right? That is the occurrence. Okay. And it's equal to 1 by n. Okay. Probability of occurrence is n. So if there are n future states, for each probability will be 1 by n. If there is 4, 1 by 4. Okay. So using this, we compute the expected payoff for each course of action, and the maximum expected value is regarded as optimal. Okay. So as you did in the mathematics classes, you know the probability of occurrence, then you make certain calculations, and you compute the expected payoff, expected result of each course of action, and the maximum expected value is taken as optimal. Okay. Laplace criteria. What is the condition of thing here? here what happens is you will choose or rather you are assuming that the probability of occurrence of each of all future states are equal. Okay, lockdown to be extended or lockdown to be continued, lockdown to be ended. Okay, these are two states of occurrence. So whatever in this case what will happen is we assume they are both are equal. That is, two possibilities are there. So 1 by 2, 1 by 2. Then we'll make the computation. We'll calculate and find out the expected result. Okay? The maximum expected value, whichever gives us maximum expected value, is regarded as optimal. We'll choose that decision, right? So once again, all these are very simple, but do keep in mind. Okay? So decisions made under uncertainty. Uncertainty occurs when there are several future states of nature, but the probabilities of each of these occurring is not known. Okay, so we are not sure about what will occur. We know there are these are all the possibilities are there. We are not sure of what will occur. Okay, in that case, we choose this. Right? So in such situations, decision makers have following tools. Right. The first one is maxi-max solution. So maxi-max solution means it deals the selecting the best possible outcome for each decision. Okay? And choosing the decision with maximum payoff. The approach is taken by optimistic decision makers and assumes that whatever the action taken, best will happen. Okay. So in maxi-max solution, what happens is there's an assumption made that whatever is the alternative we choose, we'll get the best thing. Okay. So what we'll do is we'll consider there are 4 alternatives A, B, C, and D. We'll see if we choose alternative A, what is the best thing that will happen. Okay. Alternative B, what is the best thing? Alternative C, what is the best thing? Alternative D, what is the best thing? Then we compare all the 4 best things, and we'll choose the one which is the best among them. Okay. This is with the maximum payoff. So this approach is taken by optimistic decision makers. So yeah, assumption is whatever we choose, it is the best. Whatever we may choose, nothing bad will happen. But in maxi-min solution, here what is we are taking a pessimistic approach. Okay. Here what will say? Similarly, we have 4 alternatives A, B, C, and D. We'll see what is the worst thing that will happen if we choose alternative A. Okay. Similarly, what is the worst thing that will happen if we choose alternative B? Worst thing for alternative C and worst thing for alternative D, and we'll compare those. And the alternative which gives us the least worst thing is chosen. Okay, alternative so worst outcome is least bad. That alternative is chosen. Okay. So what is the outcome of this? That is what the decision which we took will minimize our loss. Okay, so it's guaranteed that we'll have the least loss. Right? For A, we have chosen. We have seen what is the worst case. B, we have seen the worst case. C, worst case, and D, worst case. We have seen all the worst cases, and we have selected the least worst case. Okay, least worst scenario we have chosen. So that is the guarantee is there, and we'll have minimum loss. Right? Then minimax solution means it is in between. That is, we are neither pessimistic nor optimistic. We are taking a middle route. Okay. Then Laplace criteria means here what happens is the probability we have. Similarly, we have 4 occurrences, right? So alternatives are 4 state of occurrence. So all of them we assume that occurrence of all occurrences are probability of occurrence are 1 by n. So if 4 is there, 1 by 4. Okay. Then we compute the expected payoff for each course of action. We mathematically do, and the maximum expected value is regarded as optimum, which gives us maximum benefit. We'll take that as our decision. Okay. We'll compare all the alternatives, and the alternative which gives us the maximum payoff taken as optimum. Okay. So that is the decision under certainty, decision under uncertainty. Now decision under risk. Okay. In the first case, we know what is going to happen. In the second case, we don't know what is going to happen. But here, we know whatever we are doing under risk. There is a risk factor involved. Decision making under risk is the most common. Right? So we know this is the most common type. So we know what in most cases we will be making a decision the risk, like to open a restaurant, not open a restaurant, and everything will be under risk. So the steps in our first one is define the problem and identify all likely events. So what is the problem? We need to proper definition of the problem and identify all likely alternative. What is the different scenarios we may face? Then identify possible outcome for each likely alternative. Okay. So we are and we have identified the alternatives, and now we need to identify what is the outcome of each of these alternatives. Okay. So first time define the problem and identify the alternatives. Then second step is identify the possible outcomes for each of these alternatives. Then discuss the outcome based on the monetary payoff in reference to assets of time. Okay. So we are talking the outcomes based on money in money terms. Okay. So we have to spend some asset, we have to invest something, or we have to invest time. Okay. In terms of that, we'll be discussing the outcomes. Okay. That too in terms of money. Then allocate the probability of occurrence for each uncertainty. Then next we are allocating the probability. Okay, so each of these alternatives, we have 5 alternatives. For each of the alternatives, probability of occurrence, say like value, we are defining value. Then quality of the outcome depends on the quantity, quality of judgment by which alternatives were identified and probabilities were assigned. Right? That is common sense. That means we are identifying the alternatives, right? We are identifying the alternatives and we are assigning the probabilities, and that will define or that will determine the quality of the outcome, right? Then undertake a sensitivity analysis, check how sensitive the answer is to the allocated problems. Okay, sensitivity analysis we see. We have to take a sensitivity analysis to check the sensitivity, how sensitive is the. So the first method is decision making is sensitive analysis. Okay, so before that, what are the steps? First thing is we'll have to define the problem. Okay? We are making a decision for a certain under risk, right? What is under condition? We have to define the condition or define the problem. Then identify all likely alternatives. What are the different alternatives we have? So identify all those alternatives. Then identify the possible outcomes for each of these alternatives, right? Then we have to discuss the alternative in terms of money, because we are investing time and some assets into the project. So we talk about in terms of money. Okay, payoff. Then allocate a probability of occurrence for each uncertainty, right? And we are allocating probability. In Laplace, what happened? We assume that all the probability of occurrence is same. No, but here we are allocating the probability. Now what will happen is, based on, see, we are identifying the alternative, we are assigning the probability. So based that will determine the quality of our outcome. So how do we reach the outcome? That is, we do something called a sensitivity analysis. So sensitivity analysis, the degree of responsiveness of an independent variable for a given change in dependent variable is analyzed. Okay. So in math we know there are something called dependent variables and independent variables. So see, if we produce more, we have to sell more. We have more profit, right? We have dependent variable. We have independent variable. So what we see is what will happen if we change the dependent variable. Okay? The degree of responsiveness of the independent variable for given change in dependent variable. So we'll slightly change the dependent variable. Okay, if we produce less, what will happen to the profit? If we produce more, what will happen to the profit? Right? So we'll see what is happening. That is sensitivity analysis. The term is sensitivity. Okay? So it consists basically 3 steps. One is identify all variables that affect the NPV or IRR of the project. NPV means present value. IRR means rate of return. Okay, internal rate of return. NPV, net present value. Okay. Identify all variables that affect the NPV, net present value, or IRR, internal rate of return of the project. Now, NPV method of project evaluation consists of comparing the present value of all net cash inflows to the initial investment cost. Okay. So, in NPV, what is the NPV means net present value. Okay, net present value. What happens in NPV is we'll be comparing the net present value of all net cash inflows to the initial investment. We have set up a company. Like suppose we have set up a pen manufacturing company. We have made some investment, right? We have sometimes we have rented a building. We set up the machinery. We have bought the raw material. We start production. We have hired some workers. So this becomes the initial investment. Now, what is the cash inflow? Okay. What is the income from the process? What is the present value of that income? That is NPV. Okay. You compare what is the investment, what is the income. That is done with NPV method. IRR equates the present value of the future cash flows of an investment with the initial investment. Okay. So in IRR method, again, we have made an investment, right? We have made an investment. In IRR, what happens is, what is the present value of the future cash inflow? Okay. In future, we may get this much amount. Okay. We are setting up a restaurant. So in future, we will have this much of income from that. In future, we will have this much of income from the restaurant. And what is the present value of that value? If 100 rupees is the income from the estimated income in the future, what is the present value? Okay, that is considered. The IRR equates the present value of the future cash flow of an investment with the initial investment. Okay, present value of the future cash flow. Okay, if we get 100 rupees in the future, what is the value of that 100 rupees today? Right, that is the case. So NPV means net present value, IRR means initial rate of return. So first step is identify all the variables that affect the net present value and IRR of the project. NPV means present value in terms of cash inflow to the initial investment. IRR means present value of the future cash flow with the initial investment. Then establishing a mathematical relationship between the dependent and independent variables will form equations. Then studying and analyzing the impact of the changing variables. First picture we said sensitivity analysis, what will happen to the independent variable when we change the dependent variables. So that is studied. In general, projects showing greater sensitivity demonstrates more risk. Okay, if we change a little bit in the dependent variable, it shows change in the independent variable. That if it is more and more sensitive, means those projects are having more and more risk. We need to consider which one is the least. This is the least risk. Okay, that is sensitivity analysis. The second method is decision tree analysis. Okay, in decision tree analysis, it is one of the most effective methods in assessing risks in a project. A decision tree is a schematic representation of alternatives available to a decision maker and their possible consequences. Okay? So, schematic representation. Okay? So, this is an example of a decision tree. We'll see what it is. Okay? A decision tree is a schematic representation of the alternatives available to a decision maker and their possible consequences. It is composed of nodes and branches emanating from that. Okay? Square nodes denote decision points and circular node denotes chance events, and triangles denotes endpoint. Okay? The construction and reading of the decision tree is from left to right. Branches leaving the circular nodes represent chance events, and the ones leaving the are alternatives. Okay? We analyze the tree from the left to right and choose the alternative that yields the greatest return or lowest cost, maximum return or least cost. Okay. So here This is an example of a decision tree. So we read the decision tree from left to right. Okay, here the square nodes denote. So we have nodes and branches. The square nodes denote decision point, and the circular one chance. Okay, what will happen maybe like that. So see the example. See the example here. Okay, so here we are gonna have a development decision. Okay, we are going to make a product. Okay, maybe a software, maybe a new product, or maybe a new uh, tool. Okay, maybe a new style of construction. So, certain new building materials are available. Maybe a new building material. So we are development decisions is made. Okay, so there is two possibilities. That is, one is product has to be dropped, or we need to move forward. Right. So development program succeeds. So that's the chance. Okay, our development succeeds. Our idea succeeds. That's a chance. Okay, that chance after, so succeeds one chance is there, one development program fails. That's also chance is there. So suppose we have our program succeeds, then what will happen? We need to set up a plan. So we have decided to make a new building material. Okay, new type of building material for plastering. Say for plastering, we are deciding a new type of building material. So our production development program succeeded. Now next step is we need to make a plant. So that is a decision. Okay, plant, we need a plant. That's a decision. Now for what are the two alternatives for decision? We can set up a large plant, or we can set up a small plant. Okay, we can set up a large plant, or we can set up a small plant. So these two are our decisions. Okay, so what happens if we choose, if we take a chance on large plant, completion may be 12 months. For the worst case, or the best case, completion will be 8 months. If we choose a small plant, there is two possibilities, two chances are there. One is completion in 6 months, or completion in 4 months. Okay, so this is how we make. So what we'll do, we'll take the one which suits us better, that is, which gives us maximum benefit, or maximum outcome, or minimum cost. So if we are choosing a large plan, completion time 8 months best, right? If we are choosing a small plan, completion time is 4 months. Within half a time, we can complete the project. But the size of the plant is small. So like that, we'll have many alternatives we can decide upon. Right? This is how decision tree is done. So if a chance event follows a decision, choose the alternative that has the highest monetary value or the lowest expected cost. Okay. So NL takes all probable outcomes into account and makes decision making process easier. Okay. Yeah. So under risk, decision making under risk is the most common thing which we have to make. So for that, what we do first is we will define the problem and identify all the likely outcomes. Okay, alternatives are decided. Then identify possible outcomes for each likely alternatives. Okay, identify problem. Then discuss the outcomes in terms of money, because we are investing some assets of time. Based on that, we then allocate a probability. Okay, we are allocating the probability. So based on the how we allocate the probability and how much is the quality of the chosen alternative, the outcome will be good or bad, right? Then we will do sensitivity analysis. Only sensitivity analysis, or we can do decision tree analysis. So in sensitivity analysis, what happens is we'll see what happens when we change the when if we change this dependent variable, what will happen to the independent variable. So this responsiveness is analyzed. Okay. So identify all the variables and affect the NPV. NPV means net present value. IRR means internal rate of return. Okay. So NPV means, see, we are investing some amount in this. So what is the outcome income from that investment? That's the net present value. IRR means rate of return. I am investing some amount today. What is the amount that can I get from the future, and what is its present value? I may get 100 rupees in the future. Okay, what is the present value of that 100 rupees? Okay, so you can see the example for petrol or gold, right? So daily petrol price is changing. So take example like that. Okay, then we'll form a mathematical relationship. Then we'll analyze the impact of variables. Okay, and which are the alternative or the projects which show greater sensitivity gives us more risk. We have to be careful about that. Second method is decision tree analysis. Decision tree is one of the best methods. It gives a schematic representation, right? So we have the different alternatives which are possible. So we have product success, product fails, large plan can be set up, small plan can be set up in 4 months, set up in 8 months. The different alternatives are, what are the different alternatives available? It's clearly given. So there is nodes and branches. So here you can see the square nodes are the decision nodes, and the circular nodes are the chance nodes. What is chance, right? So development decision, that's the decision. Okay, this is the decision point. Okay, if the program succeeds, that's a chance event. If the program fails, what happens? Like, there are chance events. There's one more thing called triangular events that shows us the endpoint, final outcome. Okay, then construction and reading of the decision trees from left to right. Then trees analyzed from left to right, and which gives us maximum return or minimum cost is chosen. Okay? Because everything is shown properly, so we can easily get the result. Okay. So please let me know if you have any doubts.